So this is the question given here. How many pairs of positive integers m and n satisfy this equation where n is an odd integer less than 60? Uh, this question was given in CAT 2007. So how to solve this question? Firstly, I write the equation here, that is 1 upon m plus 4 upon n is equal to 1 upon 12. So this is the equation, and now when I am going to find a pair of uh, integers to put values for m and n, I have to take care of two things, that they have to be positive and n has to be an odd integer. We know that in the case of integer, what we do on number line, we have all positive integers here and all negative integers on the left hand side. So these are integers, whereas rational numbers are in the form of p upon q, means they are in fraction. Any number we can write here, so they are in fraction, but integers are usually not in fraction, but we can make them fraction, but actually they are not in fraction. They can be in fraction, or they can be in simple form, but these rational numbers will always be in the form of a fraction. So I have to find out the numbers which are not fraction for uh, for m and n. So let's find out and solve this. uh, Firstly, let me write what I do, that I transpose this uh, fraction, because the criteria here is n, because it has to be odd, it has to be positive. So what is left here on the left hand side? This one. So now I take LCM of 12 and n. We know that in the case of LCM, what we do, that we take LCM. For example, I want to take LCM of 2 and 3. In a more formal way, I can write this like this: 2 and the 2, 3, then uh, 3 1 the 3, then 1. Then for finding out the uh, LCM, what I do, I multiply. So 2 3 is 6. So 6 is the LCM. But here I have two numbers, 12 and n, and I can't do like this, but I can do one thing, that I can multiply 12 and n. What I get, it's 12n. So the LCM for this is 12n. So I can use this LCM here to solve this equation, to find out the value of m and n. So here I write the LCM 12n. What I do after finding out the LCM, we often divide the LCM by the denominator of the first fraction, denominator of the first fraction. So this is the first fraction, and this is the denominator 12. So we write 12 here as a denominator, and I put the LCM here, 12n. So what is left after solving this is only this n. So I write n here. I write n here, and there I put this minus sign. Again, in this case, I have to put this denominator here in the place of denominator, and this LCM 12n here, 12n. So what is left is only 12. So now I write 12 here. I write 12 into 4 because 4 is already here. Here I could have written 1, but doesn't it doesn't matter whether you write 2 into 1 or not, because it is 2, it leaves the number unchanged. So when you multiply a number by 1, so that's why I have not written 1 here. So it's okay whether you write or not. So now uh, I write this fraction here on the left hand side. After this I flip it. I change the position of numerators and denominators on either side. On either side I change. I put this as numerator. So it is 48. So I have found out this way for solving this equation. Now I have to find a number here that should be less than 60, that should be less than 60 and should be a positive integer for both m and n. So if I put any number less than 48, then m would be negative, because if I write if I start from less than 60 means I can start from 1 and go till 59. I can start from 1 and go till 59. But if I write any number less than 48, then what would happen, that this would be a negative integer, and in that case the result would be a negative m. So I can't write any number less than 48 here, otherwise the result would be a negative m. So I have to write any number greater than 48. I can't even write 48 because it would make it undefined. So I have to start with a number greater than 48, and the number has to be an odd integer and should be less than 60. So we can see that greater than 48, it is 49, then it is 51, then it is 53, then it is 55, then it is 57, then it is 59. So I can't go beyond this because there is a condition put that it should be the number, the end should be less than 60 and it has to be an odd number. So now what I do, I solve for I put different values for n and try to solve the this right hand side in order to find the value of m. So when I write 49 minus 48, then I write 12 into 51, and then n minus, so what is n, it is 51, so 51 minus 48 m, 12 into now 53, then 53 minus 48, and then for m 12 into 55, and 55 minus 48, and then for m 12 into 57, and 57 minus 48. I'm writing different numbers for n. N is in numerator also, in denominator also. It is here in multiplication, and here I'm subtracting 48 from n. So that's why now I can take the number different values of n here in order to find the value of m. So what I do, that the last value I can write for n is 12 into 59. So and 59 minus 48. So now I have to solve it. So when I solve it, one I have one here, and then I have to multiply this numerator only. So 12 nines are 108, so I write 8 here, 10 here, and then it's 48, 12 4 48, and then it's 50, it's 58. So it's 58. Now for this, I get here 3. So I get here, when I subtract 48 from 51, I get 3 here, and 3 4s are 12. So it's 4 multiplied by 51. So 4 and 51. So 4 1 is 4, and 4 5 is 20. So now here I can do this. I get here 5 here, 5 a 5, and here I can take this. It's 12 3 is 36. So I write 6, then 3, 3, and it's 60. 12 5 is 60, and 3. So it's 63, and 5. It would be a decimal. It would be a decimal. 5 1 is 5, then 5 2 is 10, 5 2 is 10, and then 5 1 is 5, 5 2 is 10, and let me see, check it. So 5 1 is 5, 5 2 is 10, and 1 5 3 is 15. So it is what is left here. So 5 2 is 10. So again here we can do, that a 7, we would be getting a 7 here, 7, and 12 5 is 60. We have 6 here. 12 5 is 60. It's a 66. So 7 9 is 63. So now it's 30. It's a 4. It's 2 8. So now when we solve this, for 57, we get here we get 9, it's 12, it's 57, 3 4 4. So we get 76 here. And now for the last one here, when we solve this, so here I get 2 11. Here I get 11 in the denominator, and 12 9 is 108. So 12 9 is 108, 10, so it's 70. So it's 11. So it's a fraction. Here I have a fraction. So you see that in how many results we have a fraction. We have fraction in this case, we have fraction in this case, we have a fraction even in this case. So out of these 6 values for m, we have 3 fractions. So fractions are not integers, but it is being said in this question we have to find out the positive integers. Though they are positive, but they are not integer, they are fractions, they are rational numbers. So only 3 such pairs we can have when n is an odd number and it is positive also. So the answer for this equation is that there are only three pairs. There are only three pairs.